Um, we're going to talk about the CRJ-700 today. This is the aircraft that we're going to be learning and understanding. This is the aircraft we're going to use for our flight planning. And we're going to use actual MELs for this aircraft. Who remembers what an MEL is?
Minimum equipment list.
Great. So we're going to be using the actual MELs that have been published for this aircraft. And we're going to get pretty intimate with the systems as far as like what components are on the aircraft and what is required for us to initiate, conduct, and terminate these flights using this aircraft. So the CRJ is the Canadair regional jet, the 700 model. If anybody's worked with like executive jets or knows much about like the executive jet side, this is basically a Challenger, and they put little more powerful engines on here, and then they just added a couple plugs. They relocated the APU to the exhaust out the back rather than like on the 200s where it exhausts out the side here. Changed the tail of the height of the tail. Oh my gosh. But I mean, for the most part, the platform that they used was just an executive jet that they had already built. So kind of interesting. It's a great aircraft.
So Garrett,
Yeah.
I actually worked the ramp in Salt Lake
Uh-huh.
when they got the 700 and the first 900s, and we worked the first flight of the 700 they had. It was the
Awesome.
B gate, and those things are beautiful when they're brand new.
Yeah.
Like there was no grease on the wheels anywhere like that, you know. But they're really, really cool jets.
Yeah, they're pretty jets. And you know, our fleet's getting a little older. Our CRJ fleet's getting a little older. The 200 model, which is basically just a shortened version of the same aircraft, a little bit less powerful engine, but just a shortened version. Holy cow, I'm going to have troubles tonight. A little shorter version of this aircraft. They they're pretty jets, but the 200s, you know, we fly the CRJ 200s, CRJ 700s, and CRJ 900s, and each has a very. We're really finding that they have a niche market. Each one of the aircraft do, and you know, it's kind of funny that there's not a whole lot of difference between, especially the 700 and 900, but even then we still have a very niche market for the 700 and a very niche market for the 900, and we'll go over some of those differences that make it unique and different from the other models.
Yeah.
But
these type of aircrafts are I like these specifically because they're so simple to fuel. Some Challengers I've fueled are kind of like too many buttons just in a fuel panel that you have to deal with, but for the most part these are fairly easy to fill.
yeah, and we're going to find out some of the actual problems that they do have with fueling.
They like to punctuate a lot. I noticed that with the system.
But yeah, I mean overall they're pretty good aircraft, and you know, SkyWest got rid of the Brasilia a couple years back. The Brasilia was a turboprop aircraft, and did a lot of our really short hops, like San Francisco to Monterey, or locations like that. I believe the Cedar to Salt Lake City was even a Brasilia, but we decommissioned the Brasilia. We sold all of our Brasilia fleet off, got rid of them.
Salt Lake to Twin Falls was Brasilia.
Yeah, but the CRJ-200 took over that spot, and out of the fleet of John might know better than I do, but I believe we have a total of just over 400 aircraft. 195 of those aircraft are CRJ-200s.
Yeah, I don't know the exact number of the 200s, but we have 433.
Yeah. I believe the 700s like in the 75 range, the 900s in the 90 something range, and then the ERJ, we have a little over 100 of those, I believe, now.
Are they going to start flying those into St. George pretty soon, the Embraers?
Oh, no.
No?
I don't think we'll ever see an Embraer here. Mostly, and if we do, it would just be, more for like SkyWest Appreciation Day, where we can go out and see the aircraft. And as far as using it for daily departures, I don't believe we'll ever see the ERJ down here. So, but yeah, everybody kind of talks trash on the 200, but once again, it's a very important aircraft. Hold on for just 1 minute. Sorry, guys.
How many seats are there in the ERJ?
I believe it has to be, what kind of, does SkyWest have 175s or 190s as Embraers?
I was just looking online. It looks like it's the 175.
170. I would imagine they're close to the 900 capacity of the CRJ, around that capacity of seating. I know that 200 is 50, 700 is 70, 900 is 90. I would assume it's around 95 in the Embraer.
Sorry about that. But yeah, so basically, it's just a really neat aircraft. The 700s, I believe they're mainly used with Delta. Correct me if I'm wrong on that.
United has some of them.
Yeah, just a handful, right? Just like it's a pretty small amount.
Yeah, it's very. Back when I worked in North Dakota at that airport, it was very rare that I saw a United CRJ 900 or 700. I always saw 200s.
Yeah. But, anyways, it's a really, really cool aircraft. And I actually, this last weekend, it wasn't the 700, but the 200 I got to jump seat in, and it was pretty amazing. A lot of fun. Yeah. Okay, so general information about the aircraft. The airframe type certification is the CL-600 2C10. On our dispatch release, it will notate the airframe type. So that's in some of our publications as well. It's That's the only reference you have to the airframe. You don't see CRJ-700. You see CL-600 2C10. Just a unique identifier for that aircraft. It was a collaborative effort from the manufacturers in multiple countries. GE did the power plants, Avcorp did the vertical and horizontal stabilizers. So for those of you that don't know, we'll kind of touch on the parts of an aircraft. So the vertical stabilizer is this section, the tail section of the aircraft, and then the horizontal would be this section of the tail. Basically, the tail section as a whole we call the empennage. And then, of course, your wings. This section of the aircraft is called the fuselage, the main body of the aircraft, and this would be called the cockpit. So, but anyways, so Avcorp did the basically the tail section. Manasco Aerospace did the landing gear. Rockwell Collins did the avionics. Rockwell Collins is actually in Salt Lake. At least one of their divisions is. And Allied Signal Aerospace did the APU. APU stands for Auxiliary Power Unit. We'll go over a little bit of that here in just a minute. Some of the dimensions of the CRJ-700 is it has an overall length of 106 feet and 8 inches. The wingspan is 76 feet 3 inches. The overall height, basically from the bottom of the landing gear to the very top of the tail, is 24 feet 10 inches. The main passenger door sill is only 4 foot 7 inches, and I know that very well from hitting my head going into the aircraft a couple times now. Being 6'4" isn't fun when you're on a CRJ. Oh, that's from the ground to the bottom of the door. Sorry, the door isn't very tall either. I think the door is only about 5.5 feet at very most, but I've smacked my head on it multiple times. Sorry about that. That 4 foot 7 inches allows us to have what's called air stairs on, or not air stairs, but it's equipped with stairs on the aircraft. I think you still call them air stairs, right?
Yeah.
But basically, we don't need a jet bridge or stairs to be pushed to the aircraft. We can actually just drop the door and drop the stairs and deplane that way, which helps us in our smaller airports. The pavement width required to handle this aircraft for 180 degrees, basically turning around, is 75 feet. So that's about how much pavement it takes to crank this baby around. Let's just kind of show you the dimensions. We kind of talked about this, and some of you SkyWest employees or Rampies will know this, but kind of what makes the 700 unique, and the way to identify the 700 would be the single overwing exit. So it has a longer fuselage like the 900, but then it only has a single overwing exit. The 900 has 2 overwing exits. The 700 has what's called a strake, and it's basically a fin that runs along this side of the aircraft and helps reduce the amount of pressure it takes to control the yaw of the aircraft. The 900 doesn't have the strake, but it does have 2 we call them ventral fins on the belly near the back here. But those are the main ways to identify a 700 versus a 900. The 700 meets the most stringent FAA noise requirements, so it's a pretty quiet jet. Due to the height of the tail section and the location of the APU, there's no danger area for the exhaust. I don't know if it shows that. Like I said, on the 200, the APU, the exhaust vent is right here on the aircraft. So if anybody is standing basically in this section of the aircraft and the APU is on, it's going to get really, really, really hot. Possible
Isn't it
burns.
behind? Isn't it behind the number 2 engine below it?
It's basically, I don't know exactly where the port is. I thought it was closer to the top of the aircraft, but yeah, the danger area is this section right here.
Yeah.
Um,
Yeah, the APU door is on top, on the left side of the engine, on
right
the
here.
left side of the fuselage.
So right,
Oh, okay,
right there,
yeah,
right?
and then on the opposite side, I believe, but then the APU exhaust is where your mouse just was.
Yeah. So the APU exhaust
Yeah,
is right there. Yeah. And that's what creates that danger zone. Basically, we don't want to be cooking people, burning people in the back of the aircraft. That door sill height, this is what it's talking about. It's only 4'7" off the ground to the bottom of the door. And then that height overall is measuring from the bottom of the wheel to the top of the tail. So some other kind of important things to remember on an aircraft. What are these called? These here?
flaps.
Okay, yeah, that would be your flaps. What would this section of the wing be called? This control surface, I guess.
Wouldn't it be your? Well, let's see. It wouldn't be your elevator. Your elevator's in the back.
Ailerons,
Ailerons. That's what I'm looking for.
ailerons, and multifunction spoilerons. So there is a question on the test. I know. And it asks what are the primary um, control surfaces of the aircraft? And that would be your ailerons, your multifunction spoileron, your elevator. So this tail section right here, this back half of the tail, not quite half, but back section of the tail actually moves up and down. We call that the elevator. And then the rudder basically extends from here down, and it moves from side to side like this. So the elevators control this. The rudder controls this direction, and the ailerons control roll. And so your primary control surfaces are your ailerons, multifunction spoilerons, elevator, and rudder. So everybody write that down. It's important. And we'll probably go over it again a little later in the section.
Would you be able just to message it that way you can that way you can move on? That way I'm not holding you guys up.
Okay. Let's see. So,
Thank you.
yep. So, like I said before, your ailerons are going to control your roll. Your spoilerons basically help, and it just gives it more, the ailerons more surface basically, and will help aid in slow flight. They also can be used to help slow down the aircraft, right? Multifunction spoilerons. Elevators control our pitch, our up and down movement, and the rudder controls our yaw. So so yeah, keeps it quiet. APU danger area. On the 700, our APU exhaust is actually this little tail cone here. So it removes, it's high enough and far enough away from, I guess, the ground crews that there's no immediate danger to the ground crews working the aircraft. So general points, it's equipped with one lavatory. The 900s would be equipped with two, a forward and aft. But the 700 is still only equipped with one lavatory. The flight deck door is reinforced. It carries, this is something I want you guys to write down and remember. It carries 19,594 pounds of fuel. So that's going to be really important in our flight planning, knowing that. Capable range of 1,985 nautical miles at Mach 0.74. What is Mach? Does anybody know?
Speed of sound.
Uh-huh. So it can travel basically 3/4 the speed of sound at cruise. Our cruise speed.
I got a question about the fuel. So the display when you're fueling, it goes by 10 digits. So like 10, 20, 30, and so on.
Uh-huh.
It doesn't display single digits. So how come they're giving us a specific amount of fuel when it's not?
That's just the manufacturer specification. So when they build the aircraft, that's how big they build the tanks.
Okay.
And just for kicks and giggles, the ERJ, you should see some of the numbers that they come up with on that. These are nice round numbers comparatively. So over the CRJ-200, many of the systems have been improved and others have been automated. So some of our 700s have what we call dual FMS, flight management systems, which allows us to do different things at airports. We also have some different automation for the pilots, basically frees them up a little bit, makes their job easier. So the automatic flight control system provides integration of the flight director and autopilot systems. The AFCS controls and supplies information to the dual independent flight directors The 2-axis autopilot, the automatic pitch and trim, and the 2 independent yaw dampers. So 2-axis autopilot would just be basically an autopilot that controls the aircraft on 2 axes, so roll and pitch. The dual independent flight directors we'll talk about, but basically this just makes the pilot's life easier. You'll see when you guys get in the jump seat, or if you watch airline pilots nowadays, they don't do a whole lot of actual stick and rudder flying. 90% of their job is automated anymore. And if they want it to be, pretty much 100% of their job is automated depending on the aircraft they're flying. So their job is to be there and monitor the systems and make sure they're working and be there in case of a failure. The automatic flight control system key points. The autopilot servos provide command inputs to the ailerons and elevators. The rudder is controlled by the yaw damper system. And when the autopilot is engaged, the AFCS maneuvers the aircraft while the pilot monitors the flight path by observing the flight guidance information presented on the EFIS display. And that's the EFIS we'll talk a little bit about. So yeah, like I said before, their job is basically monitoring computer systems. Let's talk about the auxiliary power unit. Now, this is a very important system for you guys to know and understand on the aircraft. So, write down APU because that is the abbreviation that we use, and then write down what it means here. It's the auxiliary power unit. So, what do you think the APU's job is?
It's to provide, basically get the systems up and running without having to use the battery, right?
So it's just a backup power unit, auxiliary, right?
Okay.
Think about a car. Do cars run off the battery once the engines are started?
No.
No. The alternator actually charges the battery while the car's running, and that's what keeps the car running, right? You could get a car started, take the cables off the battery, and it would continue running, right? So the APU is just a reserve power source. It's a generator that's fueled by jet fuel, basically. So the key points about the APU is that it's a Honeywell RE220 APU. Don't have to write that down or know what that really means. It's probably one of the only times you'll ever see it, unless you start dispatching for SkyWest, and then you'll only see it one more time. Automatic flight fault direction, so automatically detects faults and can shut down in the event of an APU fire on the ground. Automatic fire extinguishing protection. So basically, if there's a fire or something that happens, it will automatically shut down If it's a fire, it's going to automatically extinguish the fire. But again, the APU's primary function is to operate as a 40 kilovolt generator. So the main thing that you need to write down about it is that its primary function is to operate as a backup generator. That's its primary. Now, its secondary function is to provide bleed air for the air conditioning and engine starting. So write that down as well. So who knows what the bleed air is?
I don't know.
It just taps off air from the primary compressor, the initial compressor on the blades of the engine.
Yeah. Sorry, I don't want to have to keep messing up that slideshow, so I'll also show you here. Just to kind of help. Once again, I'm a visual learner, so I'm going to do what I can to help you guys understand.
There's actually a hot and cold section, and it's just that cold section that just pulls some of that pressure off.
Right. So actually, this might be a better image to go off of. It's not as confusing. So we just need to know the basic function of the engine, right? So the bleed air pulled off for air conditioning and stuff. This is a jet engine. APU engine is going to be not this. It's going to look different, but the way a jet engine works, and when we talk about bleed air off the jet engine, basically the APU is using that cold bleed air to run the air conditioning. So it's going to be pulling air from less compressed air, basically. But as far as for engine starting, it's going to be pulling, and for anti-ice, which we'll talk about a little bit later, it's going to be pulling off from later stages of the engine. So the way a jet engine works is very similar to your car. It's a four-cycle engine. It has an intake, which is the front of the engine. It compresses the air. When air is compressed, it heats up. So that's what all these fan blades are doing, is it's compressing that air and accelerating it into the combustion chamber. Once it gets to the combustion chamber, it's mixing the fuel and the air together and igniting it. So it's an explosive reaction, right? And then the exhaust phase is where it basically, pushes the exhaust, the gases out the back of the engine. So if you guys look at this and think of a car has an intake, compression, combustion, and exhaust system as well. So basically, works on the same general principle as your car engine. Just a lot more energy. Just kind of see if anybody knows. Where is most of the thrust produced on a jet engine?
I kind of don't get that question. Like, I would say in the combustion chamber, because that's where all the
That's where
'cause
the
that's where,
explosive reaction's happening.
yeah.
Well, the real purpose of it is just to produce heat, expansion heat, but on high
Right.
bypass commercial, it's that high bypass that really isn't shown in this section. It has a massive propeller, basically, a multi-blade propeller that pushes a lot of cold air past the engine.
Mm-hmm.
But that turbine part produces exhaust thrust as well.
Yeah, so I can't remember the exact figures, but basically the combustion chamber does not produce the most thrust. It would actually be the exhaust phase of the engine that's producing a vast majority of the thrust. So it's kind of backwards from what you initially think, but at the same time, it makes sense. And a high bypass engine, like he's talking about, is basically it's a turbine on the outside of the engine that spins as well and accelerates that air, that cooler air, and helps produce more thrust, additional thrust with the engine or for the engine. Um, so yeah, so its primary function or secondary function. So its primary function is to act as a backup generator, backup source of power. The secondary function is to supply the bleed air for the air conditioning and engine starting. So when they get on the ground, if they shut down the aircraft completely, then what happens is they have to get what's called a start cart out and compressed air and basically use that to kick the engine on. But what they can do is they can actually use that bleed air. They can shut down the two main engines and use the APU, the bleed air off the APU to start the engine. So if it's not going to be sitting on the ground for very long, or you know, there's other problems. Basically, they can use that APU to they can keep that APU running and use it to start the other engines. So maximum operating altitude for the APU. This is manufacturer standards. This is not SkyWest standards. We're a little more stringent on it. So basically, our maximum operating altitude would be 41,000 feet. Starting it up would be 37,000 feet. And the bleed air use would be limited to 25,000 feet and below. APU burn is 260 pounds of fuel per hour. That's another thing that's a little different than your car. We don't go by miles per gallon, we go by pounds per hour. Is how we calculate fuel on aircraft on these aircraft. So
That's actually not that much fuel burned. That's kind of good.
it depending on what's going on the aircraft, if you have to run the APU the entire flight, yeah, you'll see really quick that it adds up. So, but yeah, it compared to the other two engines when we're at cruise, it's relatively it's not very much. So. The communication system on the aircraft includes an audio integrating system It has control panels, speakers, headset jacks, oxygen mask, microphones. So oxygen mask microphones. So in case the pilots have to don their oxygen masks, they have microphones in the masks, which allow them to continue communicating. Passenger address system, um, radio tuning systems, and a CVR. So the CVR stands for Cockpit Voice Recorder. And the cockpit voice recorder records the last 2 hours of communications inside the cockpit. Why do you think that's important?
For investigations in case there's like a crash or
Yeah, exactly. I mean, it's they use it in reviewing those investigations. Now, FAA can't just go and willy-nilly demand that we supply them the recordings, but in the event of an accident, an emergency, or pilots falling asleep en route, they can access that cockpit voice recorder to determine cause. So, they have a service interphone system, so that's when the pilot's talking to the flight attendant, or yeah, um, they can talk to each other without flight attendant coming onto the flight deck and talking to them. So VHF communication systems, emergency locator transmitter. What this does is, in the event of a crash, this ELT is what we call it, will activate, and it basically sends out a signal. I can't remember how long the signal is, how long it'll run, but
I think it's 30 days, isn't it?
yeah, it's something. I think they're required to run 30 days, but I don't know that they necessarily make it that long. um, but yeah, they basically, it sends out a signal that um, will help aid search and rescue or other parties to the location of the crash. Um, it actually, if you touch down really hard, like if you had a rough landing, it can actually set off the ELT. And in that event, basically, so the Air Force is the one that monitors the frequency that these ELTs transmit on. So sometimes what happens is if there's a rough landing and it sets it off, the Air Force is going to call the office and say, we just had an ELT transmission from one of your aircraft, and they just want to know where it's at, if everything's okay. And we have to tell them, no, the pilot just landed hard. So the FDR is the flight data recorder. And we're going to talk a little more about the flight data recorder. Just a little bit. So doors, the 700 is equipped with 9 external doors. It's got overwing emergency exits on each side of the aircraft, and then it's got a forward cargo bay door. So as far as the electrical system, It uses both 115 volt AC and 28 volt DC power. The primary source of AC power, this is important to know. So I suggest you write it down. The primary source of AC, or alternating current power, is two engine-driven integrated drive generators. So IDGs is what we call them. And there's two of them. So that is a question that you will likely receive on your practical as well. But we'll find out why it's important to know that there's two of them and what the restrictions are if one of them goes out. So these CSDs, the constant speed drives, kind of act as a transmission and keep the IDGs turning at a constant RPM. So what they do is they basically prevent power surges. Say one of the IDGs starts turning faster than the other, the constant speed drive basically limits the IDG and won't allow it to turn any faster because it needs to supply a consistent amount of electricity. If it starts spinning faster, then basically it's producing more electricity and you could blow circuits and stuff. So the APU, once again, is the auxiliary power unit, and it provides that alternate source of AC electrical power. So in the event that an IGD fails, we can use the APU as an IDG to assist in keeping everything working good on the aircraft. So as far as power goes, you're going to get a lot of acronyms when we talk about aircraft. So keep them all straight. Because here's another one, ADG. This provides the emergency source of AC power. The ADG, it's kind of, has anybody seen one? Anybody know what they are?
No.
There you go. So what happens is, say there's a power failure. Kind of looks like a SkyWest aircraft too. I don't know. So if there's power failure, say one of the IDGs is out, MEL'd, and our APU is running, and all of a sudden our APU fails, and we lose power on the aircraft, the pilot can deploy this little ADG, and it works like a windmill. It will only provide power to the necessary instruments and controls and hydraulics. So it's only for emergencies. On some aircraft, you'll see basically the same exact thing, but they call it a ram air turbine or a RAT. So ADG, RAT, they're basically the same exact thing. But when these deploy, they pop out pretty quick, and you basically don't want to be standing anywhere near this thing when it comes out because it could injure you pretty bad. So the ADG also can deploy automatically when both main buses are without power. And like I said before, it may be deployed manually by the pilot in emergencies. So that ADG power is distributed to the flaps, slats, pitch trim, hydraulic 3B pump, and to AC essential buses. So ADG just stands for air-driven generator. But so that's important to remember as well, is the ADG, the air-driven generator, basically is emergency power, is what I would write down and make sure you guys understand, because that's another one that you will likely be asked at some point in time.
I'm sorry, say that one more time. It was kind of cutting in and out on my side.
So the ADG, or air-driven generator, supplies emergency power.
Okay.
Did everybody get that?
Yes, sir.
Okay.
Yep.
Okay, so the DC power is provided by 4 transformer rectifier units, also known as TRUs. And it consists of 2 NiCad batteries that store and provide a source of DC electrical power for normal and emergency operations. Not as important to understand, but oops. So AC and DC power systems utilize power centers to manage power distribution. The AP or AC Power Center, ACPC, distributes AC electrical power to 4 AC buses, and the DC Power Center distributes DC power to 9 DC buses. Again, not so important there to remember. The environmental control system, one of our favorite things down here in St. George when we get onto those hot plains. Does everybody need a break? Anybody need a break? Why don't we take a 10-minute break? Actually, let's just say let's take a break until 6:45.
Cool.
Yep.
Yep.
All right. So the environmental control system. Environmental control system key points are that the ECS, or environmental control system, provides regulated, conditioned air to the flight deck and passenger cabin. Excuse me. It consists of 2 air conditioning packs. The left one supplies air to the flight deck, and the right supplies the air to the passenger cabin. This is actually kind of a really important system on our aircraft, especially for aircraft that are operating out of St. George or Phoenix or,
Can we write this down?
what was that?
Write this down?
No, not so much. But just, if an AC pack goes out, it can be a health hazard, especially, man, excuse me, especially for places like Phoenix or, areas like that where it gets extremely hot in the summer. So, I mean, this system's pretty important. We actually, will have pilots that will reject an aircraft because it doesn't have air conditioning. And, they just don't feel like it's safe. I don't blame them too much. So, the AC packs will do more than just provide the AC. The forward and aft cargo bays are pressurized, so we can put animals in there, or your shampoo bottle doesn't blow up in the air. But only the aft cargo bay is actually air conditioned. So yeah, kind of important for people loading the aircraft up. So to know that. The conditioned air from the packs is blended with filtered recirculated air to optimize ECS performance.
I'm not sure if there's supposed to be slideshows, or is there a slideshow going through right now?
Oh, sorry. None of the information we've gone over so far has been something you had to write down so much. So we'll just keep rolling along here. I do not understand what is going on with this thing. Okay. Recirculated air can be up to 34% of the total airflow. Single pack operations. So this one is something that you do need to write down. So if we have a pack out or a single pack operation, the flight is limited to flight level 310. So that directly affects us dispatchers planning the flight, right? So yeah, write that down. Single pack operations limit us to flight level 310. So 2 dual channel system controllers monitor and control the air from the air conditioning system. So any questions on the ECS?
No, sir.
No, sir.
All right, flight controls. So the wing is an advanced technology airfoil manufactured as a single unit and bolted to the fuselage at 10 separate locations. That kind of scare you guys, knowing that the wing is only holding on to the aircraft with 10 bolts?
Very strong ones.
Yeah.
I definitely thought it would have been more secure than that.
Yeah.
Is
So
there any welding involved there at all?
yeah. Yeah.
Okay.
Not to the fuselage, but inside the wing, yeah.
Oh, okay.
But
All right, okay.
but say there's wing damage, they can actually remove the wing and put a new wing on there.
That's crazy.
Kind of a fun fact. I work for a a company that built the data links for the Global Hawk drones. I think I showed you guys a picture of what those look like, but it's a high altitude reconnaissance drone. And when they're taxiing these things, like I said, it's remotely piloted, so they have to have somebody. They have to have two people out on the ends of the wings, and then one person in front of the camera on the front of the aircraft to guide the aircraft out to a specific taxi point, and then the computers will basically, from that taxi point, the computer can taxi to the runway, take off all by itself, land by itself, and then taxi back to that point. But anyways, the taxi has to be done manually out of the hangar, and these have a 120-foot wingspan. I'll pull one up just for visual reference. So 120-foot wingspan, you can imagine this thing's pretty gigantic. Kind of makes the CRJ look like small fries. But anyways, yeah, they have to have somebody out here on each side of the wings, and then a guy standing here directing the aircraft.
I heard that they have. Sorry, continue.
We had a pilot that had been flying these for quite a while and felt like he didn't need the wing walkers to taxi the aircraft out, and just started going. Didn't watch this wing over here, and when he was taxiing it, took a turn too sharp and rammed the wing into the fence alongside the taxiway.
No.
This aircraft is like a $3 billion aircraft, and the wing was pretty expensive for them to replace. They had to get a whole brand new wing. So, yeah, that guy.
Strange looking plane too.
Yeah, that guy doesn't fly drones anymore. Doesn't even work for the military anymore. But
I heard that they have civilian contractors who fly these drones.
Not these ones.
And, well, sorry, not these ones, but they just fly like I forgot one of them specifically, but anyway, my mom has a friend who is trying to offer me to get involved in a civilian contract for the military to fly drones.
Yeah, that'd be fun.
Yeah.
As far as the civilian side, basically you have to be working directly for the program. But yeah, the company I worked for built several of the components that allow them to communicate between the aircraft and the ground and fly this aircraft. So kind of fun. But anyways, so yeah, that's the wings just bolted on with 10 bolts. So, well, 10 separate locations. I can't say 10 bolts, but 10 separate locations. So, the primary flight controls are, as I said before, the elevators, the rudder, the ailerons, and multifunction spoilerons. So, the secondary flight controls, I'd write these down as well. Are the horizontal stabilizer trim, the slats and the flaps, the multifunction spoilers, not the spoilerons, but the multifunction spoilers, the ground spoilers, aileron and rudder trim systems. So you may see this on a test. Let me know when you guys are ready.
I'm good.
All good.
All right. Everybody good?
Yep.
Yep.
Okay. Okay. In an extreme emergency, primary flight controls remain hydraulically powered by the AC motor pump 3B. So this is this 3B pump. The flight controls are powered hydraulically. The AC motor pump. So there's basically 2 engine-driven hydraulic pumps and 4 AC-driven hydraulic pumps. They're each paired. So you've got 1A and 1B, 2A, 2B, 3A, and 3B. The 3B pump is what powers only necessary flight controls when the ADG, or air-driven generator, is deployed. And we kind of saw that when we were talking about the ADG. The PCUs hydraulically move the control surfaces from mechanical inputs of the cockpit controls. So the multifunction spoilerons, we kind of pointed those out on the aircraft, operate on the downgoing wing only to assist the ailerons in control at lower speeds. So the rudder travel limiter is installed to prevent the pilot from overstressing the vertical stabilizer. The RTL monitors slat and flat positions, airspeed, weight on wheels, and engine operation to limit the rudder travel. So what this is saying is that I had an CRJ up here. Let's see. So once again, the rudder is this section. So the rudder travel limiter, basically, like I said, this moves side to side on the back of the aircraft, and the rudder travel limiter basically prevents the pilot from applying pressure too quickly to the rudder, because if there's like a full deflection, if it were to fully deflect, and quick enough, it would probably rip the rudder off the back of the aircraft or overstress it. So basically all it's doing is preventing the rudder from fully deflecting or deflecting too quickly. And that's its job. The flap system consists of one pair of inboard and outboard flaps. So the important thing to know about the flaps that I want you guys to write down once again, because it probably will be brought up again at some point on a test or in a practical. But you need to write down that the flap positions are 0, 8, 20, 30, and 45 for our takeoff configuration. Our flaps will be set at either 8 or 20 and 45 for landing. The 30 is just an intermediate setting on the way to 45 degrees. So these are degrees. 0 degrees, 8 degrees, 20 degrees, 30 degrees, and 45 degrees. And basically what flaps do is just change what we call the camber of the wings. Basically let's see.
Yeah, I noticed I was going through those index cards on our Google Drive about takeoff flaps.
Oops. So as you can see here, the wing kind of looks deformed. So that would be your spoilers, or not?
Slats.
Yeah, your slats. Sorry. So basically, we can change the shape of the wing, and what it does is it allows the wing to create more lift, but it also increases the amount of drag. So what the flaps do is they slow the aircraft down, but also provide more lift for the aircraft. So
is that why the nose always has to be? I noticed on CRJ-200s there's no such thing as slats.
right.
So they always have to point their nose down when they're trying to land, and then raise the nose right when they're over the threshold.
Every aircraft except for Navy Navy guys, because they're crazy and have to put their planes down on a small, tiny runway. But every pilot will approach the airfield at a descent angle, and then last minute they call that when they raise the nose of the aircraft, they call that the flare.
Yeah.
And that flare is just there to basically dump the speed and remaining energy of the aircraft and get it down onto the ground. So basically, when you cross the threshold of the runway, you want to dump all that energy off and basically stall the aircraft right as the wheels are touching. So yeah, that's the slats are just an aid. They help. Once again, they help increase the ability to change the shape of the wing a little bit more to help us slow down and stay more slower and give us more lift. So leading edge slats. Well, here we go. Leading edge slats are installed and consist of 3 panels on each wing. The inboard slats are the largest, the outboard are the smallest. When required, slats are anti-iced with engine bleed air. So going back to the picture of the aircraft, this front section of the wing, and right here, you can see that it's that chrome, that really high polish color, shiny metal. And what that is the anti-ice system. So they'll take the hot stage, the bleed air of the bleed air from the engine. They'll route that extremely hot air up into the wing here on this front part of the wing. And that's what they use to keep the ice off the front of the wing. Well, ice off the wing, period. Um, why do you think it's important that there's no ice on the aircraft?
Because if there was ice on the aircraft, wouldn't it be easier to stall the aircraft and have less airflow?
And it's a lot heavier.
Mm-hmm. So, yeah, just basically it changes the aerodynamic capability of the wing. and reduces the basically it reduces the lifting force of the wing. So it increases your stall speed, and when we say stall speed, it basically is the point at which the wing quits creating enough lift for the aircraft. So pretty bad stuff. A lot of accidents have happened because of icing. There was one in the 90s. It was like Air Florida or something like that. Flew up to, I think it was Newark. And, they're used to that nice, sunny, warm air. And they went and they got de-iced. And actually, they de-iced at the gate. And then they sat there for 45 minutes, which is basically long enough that the de-ice fluid that they sprayed on the jet had stopped working and was no longer keeping ice off the aircraft. So the pilot was concerned about it, but at the same time not concerned enough to go back and de-ice the airplane because he was in a long taxi line. So he decided to get really close to the plane in front of him and use that APU exhaust to blow the ice off the aircraft. Well, that's not really going to work. And when that snow melts, it's going to, turn to ice on the backside of the wing. Or, anyways, this guy decided to continue at the takeoff and got off the ground, stalled, and crashed his airplane into the Potomac River. So, yeah, it's pretty bad. Pretty bad news when aircraft get a lot of ice on them. But anyway, so those the slap positions, they're only two positions, 20 and 25 degrees. And they work in conjunction with the flap. So the slats extend before the flaps, then retract after the flaps. The slats and flaps are electrically operated. And the inboard spoilers work with the multifunction spoilers in the operation of ground lift dumping systems. So there's spoiler panels that come up on that trailing side of the wing, and basically, once again, it's changing the shape of the wing. They just lift up basically and just block the wind from flowing, block the air from flowing over the wing smoothly, and dump the lift of the wings, help slow the airplane down. So, all right, flight instruments, the EFIS. Let's see. So, when we talk about flight instruments, it consists of 4 electronic flight displays. Each pilot has what we call a PFD, or primary flight display, and an MFD, multifunctional display. So let's once again go back to good old Google. And take a look at what it is talking about here. So let's expand this all the way out. Okay, so this is what the PFD is. Each pilot, once again, has one in front of them. And this is what we call the MFD, or multifunction display. The PFD is just displaying on like a Cessna or, most general aviation aircraft, you're going to use what's called steam gauges. The PFD just combines all those necessary gauges into one screen for the pilots. Somebody
could the MFD also be known as SFD, like secondary flight display?
No.
No.
No, it's a multifunction display. So it's not a secondary. In the event that the PFD goes out, depending on the aircraft, we can switch it over to the screen that the MFD has. But
Okay.
but it's not a secondary. It's not a backup. It displays different information on it. So it'll actually display multiple functions. So the primary display displays our airspeed, or Mach, the vertical speed. So we call this a VSI, vertical speed indicator. Tells us how fast, at what rate we're climbing or descending. And it displays the altitude, or altimeter. The attitude, meaning the angle of the aircraft. The heading, the flight director command bars, the navigation information, and autopilot information. So kind of an important part of an aircraft, right? The multifunction display data includes HSI, or a heading. What is it? Heading selector indicators. Heading. Come on, pilots, help me out. The FMS map, just navigation map, shows us the TCAS, or traffic collision avoidance system. So it'll tell us, basically the TCAS allows us to see where other aircraft are. It'll provide us also with conflict resolution. So say we're coming head on with another aircraft. It'll tell one pilot that he needs to bank right and descend, and another pilot to bank left and climb to avoid each other. So kind of an important instrument. And then it also displays the radar, so weather radar, most importantly. So the two air data computers, they tell us our pressure, altitude, static air temperature, total air temperature, ISO deviation, vertical speed, indicated airspeed, Mach number. Oops. Horizontal situation indicator. There we go. Thanks, Greg. So that's right. HSI is the ball. That's what we called it on the steam gauges. So basically, it had a little ball at the bottom, and would tell us the coordinated turns. Would help us do coordinated turns. Basically, tell us the position of the tail in relationship to the nose of the aircraft. So, two air data computers calculate. So, the air data computers are down here. Okay. This is also known as the FMS. This one has dual FMS.
Garrett, where's the ACAR system?
So this screen displays our ACARs as well.
Yeah, that's what I thought. When you call it something else there.
Yeah, so here's the keypad for the ACAR system and the numbers. But basically, this is displaying all this other information for us as well. Pressure, altitude, so Mach number, true airspeed, other system parameters. Oh, I'm sorry. So the data computers actually are what are driving our instrumentation there. This is an FMS. It'll display other information pertinent to the aircraft as well. And it'll also has the ACARs on it. So anyways. So the Attitude Heading and Reference System, AHRS, it's a gyro reference system that generates angular rate and linear acceleration information about the aircraft body axis. It's combined with the heading data from the flux detector and provides highly accurate 3-axis AHRS information. So it's just giving us our position, an accurate read as far as the aircraft position in the sky, whether it's nose up, nose down, left, right, banked, yaw, whatever. So the AHRS consists of 2 computers, 2 flux detector units, and 2 compensator units. Standby flight instruments, a self-contained integrated standby indicator, provides backup altitude or attitude, altitude, airspeed, and magnetic compass information. It also displays our localizer and glide slope data. So, anyways, so here's the fuel tank system. I'd write this down. As far as the fuel tank system is concerned, it consists of 3 tanks, a left, right, and center tank. And to fuel those tanks, they call there's a single nozzle to fuel all 3 tanks. It's called single point refueling. And the fuel supplied to the engines, which flows through collector tanks. So, like Matt was talking about, that single point refueling is extremely helpful when fueling the plane. There are times, though, that
when you have to
that system stops working. And in that scenario, the aircraft has to be fueled. We call it overwing fueling. So with overwing fueling, we can only fill the left and right wing tanks we cannot use the center tank. So,
Well, I mean, can I just say something about that real quick?
Yeah.
Most of the time, well, yeah, the majority, like 99% of the time, it's not recommended to fill the center tank. But I've had those, I've had to top off the CRJ-200 before, for I don't know what reason why, I just wanted that. Yeah, you cannot put any fuel in the center until the two wings are topped off, and and um, there's also, yeah, I've had those times where being in North Dakota is extremely, it's freezing cold, and some of the pipes will, the systems won't work depending on the temperature. So um, I would always have to single point one wing and then finish off the rest on another wing by overwinging it, because the just, yeah, like I said, the pipe wouldn't open for the fuel to go in.
yeah, it's kind of interesting how it all works. So yeah, we do use the center tank, but like you said, the wings have to be full before we start.
And I believe that if you put fuel in the center tank, while you're filling the wings, I think it can throw off the center of gravity if you have passengers in certain locations of the aircraft. That's what I've been told by a pilot.
Yeah, it's I'll take your word for it. I don't know too much about fueling the CRJ, so I don't know, but I know that like in the event the single point refueling system's out of service or not working, they have to overwing it. So, and that also doesn't allow us to fill the center tank, which could possibly cause problems for us as far as long flights are concerned. So, the fuel is heated by high temperature engine oil passing through the heat exchanger. That part's not as important. As far as fuel distribution is concerned, engines and APU have separate fuel distribution center systems. The engine fuel flows from the collector tanks utilizing MotoFlow and main ejectors. The DC boost pumps are used to move fuel during engine start. The APU fuel flows from the left collector tank utilizing DC electric fuel pump. So, cross-flow is accomplished by using powered and gravity systems and is used to balance wing tank quantities. Like you said, we don't want to get too imbalanced in the wings or else it'll cause problems for the pilots. Maximum fuel imbalance for takeoff is 300 pounds, 800 pounds during en route and landing. So it's important that they fuel the tanks equally. Fuel is transferred automatically from the center to the wing tanks. Then when the wing tank fuel level drops to 94% of capacity, the fuel system computer initiates transfer automatically. So, yeah, hydraulics. So, what do the hydraulics do?
Are the hydraulics involved with the flap setting and the raising or lowering the gear? I know that has hydraulics. Does it have anything to do with the systems of the aircraft? Like if the hydraulics aren't working, some of the displays will shut off.
No.
Oh no, sorry.
No.
Like if the hydraulics aren't on, I know that certain, like, the wings won't operate and they won't move.
Well, well, the wings don't initially move, but certain flight controls do use
Okay.
different systems, hydraulic systems or pneumatics or otherwise. Different surfaces use different settings. So flaps are controlled electronically, but
Okay.
as far as the landing gear goes, yes, the landing gear is controlled by the hydraulic system. So the hydraulic system, like I said before, is equipped with 3 independent systems, and each system has 2 hydraulic pumps. The main pumps, the A's, supply normal system pressure. Pumps 1A and 2A are engine driven, kind of as I stated before. 3A is an electric pump. So in aircraft, it's super important that they are built with redundancies in the system in case of a failure. And hydraulics are a pretty important piece of the puzzle. So you see plenty of redundancy with the hydraulic system. So like I said before, 1A and 2A are engine driven. 3A is an electric pump. The backup pumps, the B pumps, supply supplementary pressure during takeoff, landing, or when pumps manually selected by the pilot. Pumps 1B and 2B, 1B, 2B, and 3B are electric pumps. And what powers the 3B pump?
Wasn't it the APU?
Close. ADG. So, in the event of a total power loss, that air-driven generator that pops out of the nose of the aircraft is what supplies energy to that 3B pump. So, yeah, as it says here, systems 1 and 2 are basically the same except for their reservoir capacities. Hydraulic system 1 powers the rudder and elevators, left aileron, outboard and multifunction spoiler panels, outboard ground spoilers, and then the left thrust reverser. Hydraulic system 2 powers the rudder and elevators as well. This one powers the aileron, the right aileron, the inboard, not the outboard, but the inboard multifunction spoiler panels, landing gear and alternate extension, right thrust reverser, and the outboard brakes. Systems 1 and 2 are cooled with the heat exchanger. So, System 3 uses 2 electric pumps, as we talked about. System 3, so System 3, like we said before, basically is our backup system. And it'll supply power to the rudder and elevators, the left and right aileron, inboard ground spoiler, the landing gear, nose wheel steering, and inboard brakes. So, System 3 has no special provision for cooling. The emergency electrical power, ADG, is provided directly to pump 3B to maintain hydraulic pressure to the flight controls during a loss of AC and engine power during flight. Let's see. So ice and rain protection. Once again, it's kind of important that we keep the ice off the aircraft because it changes our aerodynamics. The wing leading edges, slats, and engine intake nose cowls are anti-ice using the engine bleed air. As we talked about before, the windshield and air data probes are anti-iced using electrical power. So Let's see if you can see them. It's kind of hard to see them. There we go. So it's talking about these probes down here. Some of these are antennas, but there's like a probe right here. It's called a pitot tube. There's a static port. And these parts of the aircraft are basically used for the flight, the instrumentation inside the aircraft to help with things like our airspeed. Provides the airspeed, the vertical, the vertical speed indicator, the altimeter. So, pretty important part of the instrumentation of the aircraft. It
Does that
provides.
little part?
Huh?
Does that little part on the right side of the door, underneath the window, isn't that the angle of attack? Has something to do with the angle of attack?
This thing?
Yeah.
I'm not sure what that one is. This one is a pitot tube, and I know that this is a static port. I'm not so sure what that is.
Okay.
But then here's the other anti-ice. It's the areas of the wing, the engine cowls, also your elevator. Those are the areas that are. Oh, and your horizontal stabilizer as well. Those are the areas that are anti-iced. So just the leading edge, because typically, we go through that de-icing process, and typically when we're flying, this is where the ice forms, and then it just kind of spreads back over the wing. So as long as we're heating that leading edge of the wing, it's basically keeping the ice off the rest of the wing. And then here, you're sucking in all that cold air. Again, it's important that we don't have ice building up on here. If the ice breaks off and goes into the engine, it can destroy the engine pretty quickly. So we keep ice off the engines just to ensure safe operations. So here's a picture of that strake I was telling you guys about. Just that. It's kind of like on a NASCAR. You can see these same systems kind of set up on there. It just helps take the force off the flight controls. So there you can see the rudder. Can't see the elevator. You can see the slats really well there. But anyways. And the windshield is also electrically heated. So the windshield wipers suck really bad and basically don't do anything for the pilots. But they're there just to look good, I guess. So, two ice detection systems are installed, one on each side of the forward fuselage to alert pilots of impending ice conditions. The anti-ice ducting is continuously monitored for bleed air leakage. It'd be really bad if that bleed air, the piping that provides our bleed air, if that broke open at any point, could cause some severe damage to the aircraft, including but not limited to the electrical system, melting wires, the insulation off of wires, causing some serious problems. Amongst other things. So the cockpit windshields and windows are constructed of three laminated glass panels separated by two vinyl layers. Pretty hard to bust through those things. The inner surface of the outer glass panel has a conductive coating that is electrically energized for heating. I'll show you a picture of a let's see if we got a picture here. So it's what happens when you fly through hail. Pretty bad day for that pilot. Let's see if there's a little more clear of a picture. Anyways, yeah, you can see it pretty much destroyed the windshield, but it didn't break through the glass. The pilots actually had to land the aircraft looking out these side windows here. You can see that the radome here is completely destroyed. So, yeah, flying through hell, really bad.
I worked for, coming out of college, I worked for a composites company that built those first most large bypass blades on the engines, and they had to test them. So everybody liked to go to the test day because they'd throw turkeys through the engine. And, like carcasses, they'd throw the turkeys into the intakes and see if they would survive. And it's just amazing that those blades can just chop them up and throw them through the engine.
Yeah. Yeah, they're pretty powerful. But not invincible. Show you.
Couldn't at times the pilots just use autopilot if they couldn't see out the two front windows?
Well, they're always using autopilot, but
I meant for all the landing, because I know that there's autopilot on landing.
Not on all aircraft.
Okay.
That's called an auto land system that you're thinking of, that you're referring to. Not all aircraft have an auto land system. And so there's still flying that has to be done, and then when they're taxiing and things of that nature, they've got to have visual reference as well. So let's see. So here's a guy fixing some. Yeah, really bad day when those fan blades decide to break. Things like that. It also throws the engine off balance and basically can completely shred your engine pretty quick. If you have turbine
when they built those blades, they had the strongest part that they built was the shroud right around those largest blades, because when they do get imbalanced through chips or hail, it imbalances and is designed to release them so that in a orderly fashion, so that it doesn't go through the aircraft and take out 6 passengers.
Yeah.
That ring right around that outside is explosion proof. So
it's a Kevlar reinforced shrouding. Yeah. Yeah, it'd be really bad if one of those blades came through the fuselage.
But it was awesome. They would put a flaw, they'd drill a few holes in the root of them, and then spin those things up, and then either throw large quantities of water or a turkey carcass, and it would tear one loose to test it, and it would just gut the whole engine. It would just completely, the whole core of the engine would go out the back, but at least the passengers would survive.
Yeah. Yeah, it's a bad day. Ice can do the same thing, ice can, like hail, can come in. Big pieces of hail can come in and do the same thing to these engines, cause major malfunctions. So yeah, it's a bad day when that happens. And as Captain Soley could tell you, dual engine loss from bird strike, it's gonna stop both your engines, and you're gonna land in the Hudson. So
One of my friends who flies for American Eagle, he works with the first officer of that what is his name? It's first officer.
I couldn't
I
remember.
don't know his name. Yeah, I can't remember, but my friend works with him.
Huh. That's pretty interesting. That was a crazy scenario, but so yeah, those windshields are pretty strong. Don't like letting a whole lot of stuff come through them. Indicating and recording key points. The indicating and recording system consists of components that display or record critical aircraft information and system operation. Excuse me. The function of the ICAS is to display the engine instruments, visual and aural crew alert messages, and real-time interpretation of aircraft system operations. So what it's talking about here, let's see, is this system here, the ICAS. And what it's doing is it's providing real-time data to the pilots as far as the, we talked about the different stages of the engine. You got N1 speed. You have ITT, which is internal temperature of the engine, and then you've got vibration. So there's a certain amount of vibration that's allowed in the engine. Too much vibration, you start shredding it, start ripping apart the engine. And so this is the instrument that'll provide that. That instrument, the ICAS, will also provide things like these alerts to the captain when, say, the APU were to shut down and stop working. It would send a message to the pilot that say that the APU is not functioning anymore. It also tells flap position. It provides aural alerts. So when you hear like the autopilot disengage, it plays a sound. When the pilot gets too close to terrain, it plays a sound. When the pilot, any number of things. The speed, the aircraft is going too fast. You'll hear shutter sound. So I mean, there's lots of different warnings that it provides to the pilot. The other thing that you can do with it is you can also display system information. So you can display the hydraulic pumps and the hydraulic system on the panel there. You can see the doors, which doors are open still. You can see the flaps and slats. You can see basically all the necessary information, the electronics. You can see all of that information on there that provides that data to the pilot, allows him to see what's going on with the aircraft. So yeah, that's the ICAS. The 3-engine indication and crew alerting system, the ICAS, provides automatic system monitoring, integration of system monitoring, color logic for presentation of minimum and maximum limits, and then aural alert warning messages. the information is provided on 2 cathode ray tube. So for you younger people, these CRT monitors, basically, it's how we used to watch TV or play on the computers. So, so anyways, yeah, it's not an LCD screen. I think the newer ones are. The newer systems have like an LCD instead, but anyways. Master warning and caution lights are located on the glare shields. So here's your master caution and what's the other one? The master warning and caution lights are up here. These are called solar shields, basically, or glare shields, or whatever. They're covered in a piece of plastic, and you have to lift up the piece of plastic in order to push the button. But basically, when there's certain things that happen to the aircraft, it'll light up and play a sound, and then it'll give them a message here on this screen. Tells the pilot or the co-pilot what's going on, why that error is happening. Like I was flying when I was in the jump seat, we got a master caution, looked down, and the screen just said ice. So they had to turn on the anti-icing. So anyways, it's just providing all that super important, necessary information to the pilots about the systems on board. The crew alerting system, CAS, provides visual and oral alerts when the data concentrator units, the DCUs, detect a malfunction. The DCUs collect data from various aircraft systems, processes and information. The information relays it to the proper component for display. The CAS prioritizes messages by order of occurrence and order of importance. So that's this part of the screen. Red is like your master warnings, the highest priority warnings. The yellow are cautions. So anyways, it'll prioritize those emergencies or those problems for the pilots. Allows them to troubleshoot the problems in order of precedence. So there's four levels of CAS message importance. Like I said before, warning would be red, caution amber, advisory green, and status white. So the caution, they say it's amber, but to me amber is red. It's a yellow, red, yellow, and green is how I'd say it. So talking again about the ICAS, it's displaying the N1 speed, ITT, internal temperature of the engine, the N2 speed, the fuel flow, oil temperature, oil pressure gauges, and the N1 fan vibration gauges. So here's your N1 for both engines, ITT, N2, oil temper and pressure down here, and this would be your vibration. So the status page is where we see those CAS advisory and status messages. You can see the APU status, the flight number, trim settings, crew oxygen pressure, cabin pressure and temperature, brake temperature. Basically a whole lot of info about the systems on the aircraft. So it also will display the synoptic pages. So they can switch the screens. So this is like your engine settings and temperatures and stuff like that. As you can see here, the FO, the first officer, has one of the synoptic pages up. that's talking about here. So they can switch this screen to display any of this information here. The ECS hydraulic system, AC electrical system, the DC electrical system, the fuel, flight controls, anti-ice, and the doors. So they use these synoptic pages to see, like, is there a door open, or has the flight attendant closed the door and we're ready to push back from the gate? Is the anti-ice system working? Is there a leak in the bleed? The bleed valves is, what's going on with my flight controls, and so on. The ICAS message inhibit logic minimizes spurious and distracting warning or caution messages during the initial takeoff, final takeoff, and landing phases of flight. The FDR, flight data recorder, records the last 25 hours of flight data using solid state memory. So we'll talk about the FDR here in a little bit. Anyways, I'm going to call break now. So everybody, we'll do the dinner break here. All right. Well, we'll go ahead and get started. So we'll finish up the CRJ systems tonight. Let me see here. Just want to make sure we're staying on track. Yeah. Oh, we're a little ahead of the game here. That's all right. It's kind of weird how some things take a little more time, some things you can get through a little quicker. So let's see here. Let's talk about the landing gear. So the landing gear are let's see. Oh, yeah. Yeah. Well, are you planning on flying out, Marisa, for those 2 weeks?
Yes, I am. I'll be flying out.
Awesome. Awesome. Perfect. Yeah. Is anybody else taking those 2 weeks off, or?
I've already taken them off.
Awesome.
Are you talking about when we're all supposed to meet up?
Yeah, for the 2 week flight planning.
Okay, when is this? So I can write it down. Like, what weeks are it?
Week 7 and 8. So
Okay.
let's see.
Yeah, so it's only like a month out.
Yeah, pretty much
Okay.
exactly a month out. So all right. Well, let's talk about landing gear here. So landing gear standard retractable tricycle configuration. So nose wheel, two wing, two wheels that come out from underneath the wings or underneath the fuselage. Hydraulic system 3 powers the landing gear. So that 3 A and B pump will power the gear and nose wheel steering. The hydraulic systems 2 and 3 operate the brakes. So there is manual gear extension. It's kind of down here. Let's see if you can see it on one of these pictures. Almost. It's too far away. Well, basically it's right here. Let's see. It's not a CRJ. So yeah, it's right here. There's a red handle, little toggle handle that you pull up, and when you pull it up, it will manually drop um, the landing gear. So I I think is it Matt. I'm getting a lot of feedback from your speakers. Would you mind just muting your mic? You can unmute it when you need to talk or say something. That's fine. But for some reason, I'm getting a lot of feedback. It's
That's my CD. Sorry, hold on.
all right. That's better. Anyways, yeah. So the main landing gear have overheat detection. The nose wheel steering is hydraulically actuated and accomplished using a steering tiller or movement of the rudder pedals. So when they're on the ground and just kind of motoring around on the taxiways, they use this little handle here. This is called a tiller, and that's how they steer the aircraft. When they start rolling down the runway and get some speed built up, they'll use these rudder pedals. They'll steer the nose wheel with those. You don't turn the yoke here for steering. It's either on the ground. You use the rudder pedals or the tiller. So yeah. Once again, you got the ICAS, MFD, PFD. This is like a GPS. Your yoke. This is your autopilot here. You got your glare shields with your master warning and caution lights. And so on. So, this is the flaps. This is your spoilers, I want to say. Your landing gear toggle. This is where you start the engine, is up here. Anyways, I kind of like looking at those cockpit. Sorry, get a little off track there, but anyways. So the dual channel inboard and outboard anti-skid. So it's got anti-skid. Why do you think it's important to have anti-skid? Who knows how it works? Anybody?
Wouldn't anti-skid be used in rainy and snowy conditions?
So,
Or
Is it the same as anti-lock brakes?
so an anti-skid is basically anti-lock brakes for an aircraft. Just for fun and to kind of break up the boredom. Let's watch a video on how they test these anti-brake or anti-skid systems. let's see. Nice big airplane here. So basically what it does is it will release the brakes in the event that, ooh, here we go. In the event of a wheel locking up, basically it will unlock it and allow it to roll while the others continue braking to prevent the aircraft from skidding. So everybody pull that up, mute your mics, and watch that. It's a pretty quick video. But you can see how they test these anti-skid systems. Everybody get a chance to watch it.
Yeah.
So basically what they do is they get to that, we call it V1, takeoff decision speed, which in the CRJ would be, anywhere from 127 knots about to like 142, just depending. They get up to that speed and then they just slam on the brakes. And if basically the brakes fail, then they know it doesn't work. If it stops and everything holds up, then hooray, it worked. So I always thought it'd be really scary to do that, be the pilot, lock up the brakes or lose your tire or something like that and just cream the plane into the ground. But
Who actually agrees to do that? Just anybody, or does somebody have to be like specifically trained for a crisis in order, like in case that
Yeah.
fails?
so
You
it's
have to
just,
be a test pilot.
yeah, it's the test pilots. So they're test pilots are usually pretty senior guys um, that have a lot of experience, flight experience and stuff like that. So
Gotcha. Okay.
I don't know if you've ever seen a video of an emergency landing at LAX of a guy of a pilot. His nose gear was tilted the opposite direction, and when he touched down on his nose, he basically just burned off his whole entire tire, and there was no rubber left as soon as it came to a complete stop on the runway.
yeah, I've seen that one.
Oh, okay.
Lights on fire and sparks
Oh
shooting
yeah.
out down the entire length of the runway.
For whatever reason, before this class started, I decided that I wanted to start watching like all of the plane crashing documentaries. Give myself a good scare. Like,
Yeah.
so I've seen a bunch of weird Weird stuff.
Yeah. Yeah, they I guess up in the operations control center where the dispatchers sit at SkyWest, they'd had one of the TVs playing the Weather Channel. Well, later at night, the Weather Channel turns in, a lot of the plane crash, like investigation news stories play, and one of the dispatchers was finally like, "Is this really something we should be watching?" As far as like these plane investigation or the crashes and stuff.
Gonna bring a morale down.
Yeah. So
I can't help it. I think they're interesting.
yeah, they're really interesting, but yeah, kind of funny. Just the irony of that.
Mm-hmm.
So, anyways, so yeah, the anti-skid just basically it'll keep the wheels from locking up and allow the plane to continue to roll but slow down at a safe rate. So, um, yeah, kind of interesting how that system works. But the BTMS is the brake temperature monitoring system. Monitors temperature of each brake. Those brakes that we just saw were nice cherry red, all but catching on fire at that point. But the display is color coded, and a numerical readout on the ICAS is displayed on the ICAS status page. So, on the CRJ-700, there's also a tail skid plate, and basically it prevents the tail cone from making ground contact in the event of a high rotation pitch angle during aircraft takeoff. Let's see. So
I always like
it doesn't
seeing
look.
the test videos of them retracting the landing gear.
What was that?
I always like watching the videos of them testing the retracting the landing gear.
Yeah. Yeah, it's pretty interesting stuff. But anyways, there's a plate that basically drops out of the back of the aircraft. And when they're taking off, if they basically lift off the ground too fast, so this is a 200, but if they lift off the ground too fast, the plate sticks out from the bottom here. And it just allows, like, instead of the entire tail cone scraping, it just scrapes that really thick sheet of metal and won't allow uh, damage to happen to the rest of the tail. So that's all that's talking about. So aircraft lighting. Lighting system includes external lighting, flight deck lighting, passenger compartment lighting, service compartment lighting, and emergency lighting. So to identify an aircraft, we have what's called the navigation lights. These are red, green, and white lights on the aircraft in specific locations. There's also the anti-collision strobe light, rotating beacons, logo lights, and wing inspection lights. So you can kind of see on that picture right there. So the left wing here, on the very end, there's a light there called this is one of the navigation lights. And you'll see these lights on boats too. Boats have the same exact lighting pattern. But the left wing has a red light, the right wing has a green light, and then up on the top here and on the bottom, there's two red rotating beacons, and then there's also lights. There's also a white light, and I can't remember where it's at on this aircraft. I think it's up here, but a
They're
white.
on the tail.
So yeah. Oh, there. It'd be up here somewhere. Anyways.
I see it. It's right on
Oh,
the
right
very
there.
back
Right there.
blower. Okay.
So yeah, I think there's one forward and aft actually. Thinking about it. But anyways, these lights will at nighttime you can see which direction an airplane is going due to the lighting system. If you see a red and a white, two whites, then you'd know that the aircraft was moving from the right to the left. If you saw a green and two whites, you know that the aircraft is moving from the left to the right. And then if you see a green, white, and red, then you know that the aircraft is moving either away from you or towards you. So, but then there's also a strobe light, and that's on the bottom of the aircraft typically. There's also wing strobes as well, I believe. But anyways, just to identify what's going on, this would be your logo light here. Just displays the logo on the tail. You got wing inspection lights that are over here on the side of the cabin that basically shine onto the wing so the pilots can see the wing in low light for their checks. And then on the front main gear is called, there's the landing and taxi lights. So, so yeah. Oh, and then you also have on the inboard part of the wing here, you have landing lights as well. So you have a landing light on the nose, and then you have the landing lights here on the inboard part of the wing. So for emergency lighting, you have a wall and floor level exit signs. You have ceiling and floor level emergency floodlights, and then a floor track photoluminescent tape. I'm sure you guys have all seen that on the ground of the aircraft. For navigation system, the 700s are equipped with dual VHF, DME, and localizer navigation systems. They also have dual ADFs, dual marker beacon systems, dual transponder systems. Their EGIP-WIS, or enhanced ground proximity warning system, basically is that instrumentation that tells them, their altitude when they're coming in for a landing. We've listened to it on a couple of the approach videos that we've watched. They also have the weather radar, TCAS, and GPS. Who remembers what the TCAS is?
Traffic collision avoidance system.
Perfect. So each navigation radio is capable of receiving a VORE, DME, and 2 additional DME channels. 2 radio tuning units are installed on the aircraft. And then the TCAS provides resolution and advisory for traffic considered a threat within 25 seconds. So like I said, if you're going head-to-head with another aircraft, or even coming up on an aircraft from behind too quickly, it'll provide you resolution advisory. So it'll tell Each aircraft has one equipped in it, and like I said before, the two TCAS systems will talk to each other. One will tell one aircraft to climb and turn right, or descend and turn left, or vice versa, in order to avoid the traffic. So the EGIPWIS ground proximity warning system gives you altitude callouts. It'll warn you of excessive bank angles or excessive descent rates or excessive terrain closure rates. So when you hear like terrain, pull up, like that's the EGIPWIS yelling at the pilots. Also notify the pilots of unsafe terrain clearance, altitude loss after takeoff, and wind shear detection and alerting. So who knows what wind shear is?
That excessive crosswind.
Yeah, it doesn't typically wind shear can happen any direction in any angle.
Yeah, isn't wind shear? Yeah, when you're say you're trapped, you're landing on 3-1, and the winds are, let's see, it's basically when the wind changes direction and your airspeed indicator like gains more speed, right?
Well, not necessarily that so much, but basically it's a sudden change in wind speed in excess of, I can't remember the exact speed, but it's like 30 knots or 40 knots or something like that. So basically it's just a really rapid change of wind direction and speed. And that's really important. When aircraft are coming in for a landing, if there's a sudden change in wind and speed, it could create serious problems for the aircraft. So, oxygen emergency equipment. So, oxygen emergency equipment, key points. The oxygen is supplied to the flight crew, flight attendants, and passengers during an emergency. Y'all have heard the the whole flight attendant spiel. So the flight deck has its own oxygen bottle, and the flight attendant and passenger drop-down oxygen masks are supplied by chemical oxygen generators. So the passengers, basically that mask, when you know how the flight attendant tells you when the masks are deployed, you need to pull down on them. Well, when the passenger pulls down on that mask, basically it triggers the chemical reaction, and will start flowing the oxygen to the mask. Well, that chemical reaction, just like any chemical reaction, only lasts a certain amount of time before it shuts off. Basically, what happens is the oxygen that is supplied to those masks will only last long enough for the pilot to descend to a safe altitude, which is, I believe, 12,000 feet. Is the altitude that they say is that safe altitude. So basically, as soon as those masks are deployed, the pilots have to start a pretty rapid descent to get down to that altitude before the oxygen runs out for the passengers, because they don't want to put them to sleep. But the pilots are actually supplied their own oxygen bottle, and they technically could fly for a lot longer than that, if they needed to. So there's also therapeutic oxygen that's available from portable oxygen cylinders that flight attendants can use to take care of passengers. The crew masks are full face, quick donning, and equipped with a microphone. There's chemical generators that provide oxygen for 13 minutes. There's your time limit. So basically, as soon as those masks, as soon as you pull down on that cord, pilots have 13 minutes to get you down to 12,000 feet. So passenger masks are automatically deployed at a cabin altitude at or above 14,000 feet. Passenger masks can be deployed manually from the cockpit as well. There was actually a CRJ, a pilot accidentally deployed the oxygen masks not too long ago. Said he was swatting at a fly in the cockpit and accidentally hit the button to deploy the oxygen masks. And luckily nobody put the oxygen mask. The flight attendant was able to make an announcement quick enough that there was no need to put the oxygen masks on, but pretty sure it scared the crap out of a lot of people. PBE, protective breathing equipment units, are installed in the flight deck and passenger cabin to provide oxygen and smoke protection for crew members. It's kind of funny, the flight attendants, this portable bottle, they have like one of those old grandma oxygen bottles that they'll use when there's a cabin depressurization. And so they put on these masks. They look like the bodysuits from Outbreak. Basically, it's like that headgear. And they throw that on, and then they wheel around a portable oxygen bottle. And it's kind of funny looking. But other emergency equipment that the crew has is fire axe, fire extinguishers, overhead hatch escape rope. So there's actually an overhead hatch in the cockpit that the pilots can use for egress in the event of a crash or an emergency. So there's just an escape rope that they'll throw out when they open up that hatch. There's life vests only provided for the crew, actually. The passengers have their seat cushions that they can pull off. They also have infant life vests. So, because they can't get their arms through those seat cushions, but there's flashlights, overwing emergency exit escape ropes. We don't have a slide on this CRJ, and a megaphone. So pneumatics air system, right? So during most phases of flight, the engines supply the bleed air for system operations, and pneumatic system is managed automatically. So basically, it's pulling some of that hot air and cold air off the engine to provide, things like engine starting, cowl and wing anti-ice, and also the air conditioning. The pneumatic systems receive pressurized air from either the 6th or the 10th stage of the left or right engine compressors. The APU, from the left or right engine compressors, the APU, or from external ground source. So when they have the start cart or the compressed air hooked up to the aircraft, they can also use that to run the air conditioning on the ground. So, and then there's a common bleed air manifold that distributes the bleed air. Bleed air management system is fully automated, with manual control available for non-normal operations. To minimize damage from the bleed air leak, the pneumatic ducts are continuously monitored by the bleed air leak detection system, which they can view from those synoptic pages on the MFD or multi-function display. The sixth stage of the engine compressor supplies air to operate the pneumatically powered systems. When the system demand exceeds capacity of the sixth stage, the high pressure valves automatically open to supply pressure from the 10th stage bleed air to the manifold. So the sixth stage is where we get the air from until basically the system exceeds the capacity of the sixth stage. So basically there's too much demand and the sixth stage can't provide enough of that bleed air. So once it exceeds that demand, it'll open up the 10th stage to supplement it. The power plants. So the CRJ-700 is equipped with two GE CF34 8 Charlie 1s or 8 Charlie 5 Bravo 1s high bypass turbofans. So basically just different performing engines. The Bravo 1s are a little more powerful, have a little bit higher thrust rating than the 8 Charlie 1s, but normal takeoff thrust rating is 12,670 pounds. And then if one engine fails, they can operate one engine with the APR and basically get 13,790 pounds of thrust. So if one engine fails, they can basically push more power through the engine that's left. The engines are flat rated to ISA plus 15 degrees Celsius at sea level, and each power plant is controlled by a full authority digital electronic control system. Or engine on the ERJs we call it digital electronic control system. On the CRJs we call it engine control system. So FADEC is what we call it. Both do the same exact thing. So the engine has two independent major assemblies, the N1 and N2 fans. So yeah, the N1 section consists of a fan rotor that is driven through a shaft by a 4-stage low-pressure turbine. And then the N2 section is comprised of 10-stage axial flow compressor, combustor, accessory gearbox, and 2-stage high-pressure turbine. So think of that engine. Again, let's see. I might have it pulled up still. So basically your N1 is these forward and N2. Is that right? Greg, you're the jet engine expert.
Yeah, just that forward is the initial compression.
Yeah.
And then as the blades get smaller and closer together, it increases compression ratio on each stage.
Yeah. So your N1 would be this forward part, and then N2.
Right.
So they monitor that. They basically don't want to. The reason why we monitor the blade speed, the rotation speed, the RPMs, is because if they get moving too fast, basically they stop producing that thrust. We have what's called a compressor stall, and basically the engine just stops producing thrust. Can really mess you up. So
That's a technical term.
yeah, I think so. Yeah. So the engine airflow passes through the single stage fan and is divided into two airflow paths, as we saw in that picture, the bypass and core air. Bypass air is accelerated by the N1 fan and is ducted around the engine nacelle to produce the most of the engine thrust generated at takeoff. Then the core is accelerated by the N1 fan, or core air is accelerated by the N1 fan, then enters the N2 core, where it is compressed, mixed with fuel, and ignited. So let's see, they got this. There you go. So N1 and N2. It's basically this section here. And what it's saying is the N1 fan, this high bypass, is flowing the air over the top of the engine here. You can see that cowling there, or you can see it there. You can see it there, there. So that's producing the majority of the thrust. But then the N2 stage, that's providing the combustion. So yeah, this is your high bypass turbofan. The N1 fan is a single stage fan that consists of 28 titanium alloy blades. A Kevlar blanket is wrapped around the fan housing to contain possible damage from the failed N1 fan. Like I said, you don't want to get messed up by that fan blade blowing through that engine housing. So,
Garrett, just another point, doubling back to wind shear. They also did wind shear tests on those high bypass fans. So what they would do is they just had a high-speed injection air, tangential or perpendicular to the flight path of the air going in the engine. So they would just shoot this big explosive burst of air across the intake, and it would stall the compressor blades because it's just like a wing. It's an airfoil.
right.
And when the relative wind changes, they just completely stall. It shuts down the engine combustion, but it also overspeeds the drive system, so the transmission just completely explodes if the wind shear is significant enough across the face of the engine. It's just spectacular to watch it happen.
Yeah. Like I said, it'll mess you up. That's a technical term. So
We write that down.
please do. No.
No, you need to make that an acronym.
So
then you are M, which is the 10% mess.
exactly. You guys got it. But yeah, that's kind of interesting. I know they are put through pretty rigorous tests. It's kind of interesting here how these things are tested as well.
You wonder why the company, the subcontractor I worked with, you wonder why the engines are multi-million, many millions of dollars is all that testing. I mean, it's not just enough to build the engine. They have to spend so much money testing that engine and certifying it.
Yeah, it's just I mean, like I said, I worked manufacturing as well, building avionic systems and stuff like that for these drones and actually for like Apaches and stuff as well. And yeah, it's amazing the amount of testing and the cost that goes into that alone. Just developing the product. So yeah, it's awesome. So a fuel oil heat exchanger is used to warm the engine fuel and cool the engine oil. So it's kind of a symbiotic relationship there. You know, we don't want the fuel too cold. Fuel evaporates extremely fast. and that's why it tends to feel really cold on your hands. Say you spill gas on your hands, it's evaporating really quick, so it's inherently cold. And engine oil, when it's getting pumped through these engines, gets extremely hot. So, and then you got to think about the flight level that these aircraft are flying at as well. Up at 34,000 feet, kind of your standard temperature is going to be in the range of negative 53 degrees. So if that fuel system freezes up, it's kind of a bad thing. So basically, they pump the engine oil around the fuel tanks and stuff like that to cool. Well, I guess, yeah, next to the fuel to cool the engine oil, and then it also heats up the gas at the same time. So they help each other out there. The FADEC, or Full Authority Digital Engine Control System. Each power plant has its own dual channel FADEC, and one channel is to control, processing information to provide engine control outputs, and then the other channel operates in standby mode. Just in case, like I said before, a lot of redundancies when it comes to flight. In the in-control and standby channels continuously share command and status data through crosstalk data bus. Should the designated in-control channel become unserviceable, the standby channel assumes the in-control role. Like I said, redundancy. The FADEC system has its own source of electrical power. So, yeah, you have multiple fault systems for these FADECs. So, depending on the fault, it could cause problems for our flight planning. So engine idle, when the thrust lever is placed in idle, the minimum N2 idle RPM is programmed by the FADEC. The idle RPM is dependent on the atmospheric information, bleed air loading, and the phase of flight. So the FADEC's basically always keeping it at the appropriate speed, and the best performance, to provide the best performance of the engine. Like I said before, they talk to each other. They're talking to each other, and then if there's a difference in the N1 fan speed that exceeds 15%, the FADEC automatically increases the N1 speed of the operable engine. So, if one engine starts slipping, basically the other engine will pick up the slack. The APR, we talked about this. The APR, in the event of an engine failure, will increase the thrust of the remaining engine. The automatic performance reserve, or APR, available during normal and reduced takeoff and landing phases. So we arm the APR for takeoff and landing. The FADEC automatically computes a target thrust setting for the selected thrust lever position. So, we can do what's called a flex or a reduced thrust takeoff. And basically what that means is that when an aircraft, so your standard takeoff that we see, the aircraft will roll onto the runway, line up with the center line, come to a full stop. Then the pilot will put on the brakes and increase the throttle, because these turbines have to do what's called spool up. They got the N1, those fan blades, they got to spool up and get to the right speed before it starts providing the proper amount of thrust to take off. So these reduced or flexed takeoffs is when the pilot, he'll just kind of roll onto the runway and slowly increase the throttle and without coming to a stop. And basically what that's doing is that's reducing the wear and tear on the engine. But where there's benefit, there's also a takeaway. Reduced thrust or flex takeoffs, they also require a lot more runway because your ground roll is longer. You're not getting that instantaneous thrust from the engine. You're just slowly increasing the throttles. So your takeoff roll is extended pretty dramatically. So it's kind of like the difference between a cross-country runner and a sprinter. So the engine and bleed air, like we said before, are extracted from the 6th and 10th stage of the engine compressor. And we've said all of that. Thrust lever settings. So the throttle got shut off, idle, climb, toga, max power, and then cruise settings between idle and climb. Thrust reverser system. So when we land, what happens is on the back of the engine. Let's see if we can find a picture of it. What happens is the back part of the engine housing will slide backwards and direct the thrust. There's some plates that kind of extend out, and it directs the thrust forward instead of out of the back of the engine. And that it's kind of like air brakes, right? I mean, you're instead of that thrust coming out the back of the engine, you're forcing that thrust forward, and it helps you slow down dramatically. So don't always have to use the thrust reverser, but it really helps save the brakes, save wear and tear on the brakes and the braking system. But at the same time, with the bad, with the good, there's also bad. Once again, and it can slowly wear on the engine as well. So the thrust reverser responds to electrical signals from the FADEC and thrust reverser levels, accomplished by blocking and redirecting the air forward, as we stated before. The reversers are hydraulically actuated. The left engine reverser is powered by hydraulic system 1, and the right engine reverser is powered by hydraulic system 2. So water and waste. So we need potable water and wastewater on these aircrafts. The wastewater, people got to use the lav. So not too much to say about this. It's pretty self-explanatory. Kind of a food for thought idea with this waste and water is think about these water trucks that supply the potable water for these aircraft. It's not like clean spring water exactly. I don't know. Probably lean on the side of caution and just don't drink the coffee on an airplane. I'm sure airport facility does a good job of maintaining these trucks. I'm just saying, personal preference. It's not, just doesn't sound too appetizing. I don't even drink the water from my trailer. I only use that for doing dishes and flushing the toilet. So
this isn't the first time I've heard that. Don't drink the coffee on a plane. So it must be true. I don't know where I've heard it before, but I've heard it before right now. So,
but yeah, I mean, it's I don't know. Like I said, I do a good job of like bleaching my tanks on my trailer and everything. I keep up on it, but I will not drink the water from my trailer. It's full of bottled
there's just
water for a reason.
something about stored water. Just, I get it.
Yep.
Yeah.
But yeah, I just kind of compare the water tanks on the aircraft to the water tanks on my trailer. Got an electronic pump that moves water and things of that nature. It has a black water tank basically that'll hold the wastewater. And I wouldn't want to be the guy that has to go and drain the tanks, these black water tanks. I was talking, one of the guys that I work with, he was a rampy for Southwest Airlines in Georgia, and he said that the guy that bids the wastewater truck is actually like the most senior guy, and it's like a highly sought after position for some reason. It's beyond me. I don't understand it, but
it's super easy. A lot of times you just sit there until they call for it because you don't do it on every plane. We had one guy on the E-gates that he would sit there. It was actually a cart that you pull behind one of the tugs. And as long as you're careful, I would just like double check everything if I ever had to do it. And so I never got anything dumped on me or anything like that. It's for guys that get in a hurry, not paying attention, that if you don't click that hose on tight, you pull the handle and next thing you know, you're covered in crap. And I would click it like 3 times, click, 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 just making sure it's on there tight. But no, there's one guy that wanted to do it all the time. And most of the time he's sitting in the, in the break room, just waiting with his radio.
So,
to be honest, that happened to me my first time when I did a lab. It was when I was getting trained at the FBI, and then the guys are like, "Hey, you want to do it?" I'm like, "Sure." And then he's all telling me, "Well, make sure you hear 2 clicks, because if you don't hear 2 clicks, you're gonna regret it." I'm like, "Okay." I thought I heard 2 clicks, and sure enough, it fell out while it was coming down. I was like, "Ah!"
That's so gross. I remember the first time that I was dumping my trailer, and I hooked the hose on, and didn't realize that it came out so quickly, and the hose popped out of the off the holds, and like I kicked that valve so quick, shut it off. But it was, yeah, I've never done it since for a good reason. I'm always very cautious now. And that was the first time I ever took my trailer out, so kind of ingrains that in your head how careful you gotta be. It wasn't fun. I could imagine coming off an aircraft, it's probably worse, especially when you have that many people using it. So, anyways, fun times. That finishes off our PowerPoint. We went through 117 slides, guys. That's pretty good in one night.
Woohoo!
So Does anybody have any questions about the CRJ systems? Any
I'd say
interesting, fun stories?
There's one question that I didn't get, and it would be, let's see. Hold on, let me go to it real quick. Oh, never mind. Sorry, I thought I didn't answer it, but it's already answered. So,
Oops.
yeah, never mind.
All right. So, like I said before, or like always, I put the PowerPoint in here. There's also the manual for the CRJ. It goes through all that information just in more of a dictionary type form for you if you want to look at that. But that one's only 21 pages versus our 117 pages on the PowerPoint. But you're welcome to go back through it. Also, here is the link to when Adam taught the CRJ, the first part of the CRJ systems. So, anyways, if you guys don't have any questions, we can just call it a night.
Alrighty.
Sounds good. Thanks, Garrett.
Yeah, no problem.
Yeah, thanks.
Thank you.
Cool. See you guys tomorrow, guys.
Yep.
We'll see you.
Have a good night.